Welcome all of you. Today we discuss about the practical. That means first practical, and the practical name is visit to Agromet observatory. From today we are study about the practical exercise or practical syllabus. There are near about 17 exercises included in your practical syllabus. In that, first and second practical in syllabus, in our syllabus, first and second practical is the visit to agromet or agrometeorological observatory, their site selection of observatory, also exposure of instrument, that means the installation of instrument and recording of weather data. That means in this lecture we are discuss about the what is meant by agromet observatory. Also we discuss about the procedure, that means during the installation of agromet observatory which point should we consider, also which procedure should we follow. Or also we discuss different instrument which are used to useful or used to recording different climatic or weather element. In that we discuss about the instrumental and non-instrumental observation. Also we are discuss on the point like recording of observation of on plants, also hours and orders of observation, that means at which time the observation of the different weather parameter should be recorded. There are several different parameters. They different parameters have a different time of observation in observatory. It is based upon the Indian standard time. Also we discuss about the this recorded weather data, it is transferred to IMD, that means the network of IMD, also the recording and transmission of the data or climatic data to the IMD, that means India Meteorological Department. Also we discuss about the classification of agromet observatory, that means the types of agromet observatory. So these different points we are discussed in this topic. In this topic there are one point is the classification of agromet observatory. I think this classification of agromet observatory or the page of classification of agromet observatory is missing in our practical manual. So during the watching this video, or at the time of watching this video, the point should be noted, that means the classification of or types of agromet observatory should be note down in our practical manual in any one page. Or also you can note down the classification of type of agromet observatory in any notebook or any register. It is important for the semester practical same exam purpose, the classification of type of agromet observatory. So firstly, and also during watching this video, or at the time of watching this video, the student, it the practical manual or practical manual is used during the watching this video. For the better understanding, at the time of watching this video the practical manual is also used, or after watching this video the practical manual can be read for the better understanding. So now we discuss about the our first and second practical, that means the visit to agrometeorological observatory, their site selection, exposure of instrument and weather data recording. So first one, before studying this visit of agrometeorological observatory exercise, firstly we discuss about the role of agricultural meteorology. In theory lecture we are already study about the scope and importance of agricultural meteorology. Just in this lecture we are enlisted the role, that means scope and importance of agrometeorology or agricultural meteorology, and after we discuss about our practical exercise. So first one, the role of agricultural meteorology. First role, to study the climate. Next one, study of microclimate. Also the forecasting, study of forecasting. Also crop geometry. Here crop geometry, this is the new terminology. The climate, microclimate, forecasting. This terminology already we are discussed in theory syllabus. Here new terminology is crop geometry. What is meant by crop geometry? Crop geometry means the area occupied by the single or individual plants. The area occupied by the single or individual plants. It is known as the crop geometry. That means from their root system to uh, uh, top of the height of the crop. Also from this leaves to the this leaf. That means north to south or east to west. How many area is occupied by the single or individual crop? It is known as the crop geometry. This terminology again important for the third semester in agro 3235 course. Now the next, remote sensing. Remote sensing in upper air observation. For the cloud observation also remote sensing is used. Also the meteorological application, that means the use of meteorology in relation to agriculture and general. So these are the role of agricultural meteorology. So this is about the role of agricultural meteorology. Now the next, what is meant by Agromet observatory or agricultural or agrometeorological observatory? So here Agromet observatory means it is the observatory. It is the observatory. It is situated or installed at any city or any area, and this observatory is installed for the purpose of recording climatic or climate or weather element, and by recording weather element find out the relation between crop and their environment. To find out the relationship between the crop and their environment or crop and their climates. So this is known as the Agromet observatory. That means in simple language, observatory or Agromet observatory means the observatory which is installed at any place or any city to recording the different weather or climatic parameters, and to find out the relation between and their environment or crop or climate. So this is known as the agrometeorological observatory. In scientific meaning or scientific language, what is meant by Agromet observatory? In scientific language or scientific meaning of Agromet observatory is the Agromet observatory are specialized observatories to record data in crop environment required to understand crop climate interaction, and are different from those set up in the cities and aerodromes. That means any area the observatory is installed for recording crop as well as the weather data, and after that recording weather data and crop data, it is useful to find out the relationship between crop and climate. That means the negative as well as positive impact of the weather parameter or climatic parameters on the crop. This is found by the using climatic or with by recording weather parameters in observatory. So this is the meaning of the Agromet observatory. In another words, what is meant by Agromet observatory? In another words, Agromet observatory are the station at which element of climate related to agriculture are observed to explore crop environment relationship. That means at any station or any observatory, weather elements are recorded. Those are related to agricultural, and finally find out or explore the crop environment relationship. That means negative and positive impact of weather parameter on crop or on agriculture. It is find out by the recording different weather parameters in observatory. So this is known as the Agromet observatory. Now next point, See here, it is the Agromet observatory. It is the layout, or it is a picture of layout of observatory or observatory. Here different weather parameter are installed. See here, this is the wind vane single Stevenson screen. The third one is the non-recording rain gauge. Here soil thermometer. See here, this is the sunshine recorder. This is the open pan anemometer. Next one, see here, this is the anemometer. This is the double Stevenson screen. This green part, it is the self recording rain gauge, and here it is the dew gauge is installed. So this is the Agromet observatory. That means here different weather parameter like wind direction, temperature, uh, also rainfall, also soil temperature. Here also bright sunshine hours, that means solar radiation. Here also evaporation. Here dew fall. Here also rainfall temperature. And here by using this instrument, speed of wind is recorded, and finally find out the effect of this weather parameter on crops, that means negative and positive effects. So this all is known as the Agromet observatory or agrometeorological observatory. So this is about the agrometeorological observatory. Now we discuss about the next point. So see here, this is our college Agromet observatory in our college campus, and this observatory also included the different weather install the different instrument for recording the different weather parameters. And such types of agrometry, that means Agromet observatory, it is set up by the Agriculture Meteorological Division by India. That means the Agriculture Meteorological Division, it is a part of IMD. IMD means India Meteorological Division, and this Agricultural Meteorology Division of India, it is set up or established at Pune. In case of network of IMD, at that time we also discuss in details what is meant by Agricultural Meteorological Division. That means here म्हणजे मला या ठिकाणी काय सांगायचं आहे की ॲग्रिकल्चर मेट्रोलॉजी डिव्हिजन जे आहे पुण्याला, तर ती डिव्हिजन काय करते की वेगवेगळ्या ठिकाणी किंवा मग स्टेट ॲग्रिकल्चर युनिव्हर्सिटी असेल, म्हणजे जसे आपली राहुरी आहे, परभणी आहे, अशा वेगवेगळ्या युनिव्हर्सिटी आहेत. अशा वेगवेगळ्या युनिव्हर्सिटीमध्ये काय करते, ॲग्रिकल्चर मेट्रोलॉजी डिव्हिजन काय करते, ॲग्रोमेट ऑब्झर्वेटरी इन्स्टॉल करते. मग ते रिसर्च स्टेशन असू शकतं, म्हणजे सोलापूरचं जसं ZARS आहे, जर्नल ॲग्रिकल्चर रिसर्च असेल, किंवा कोणतीही KVK असेल. अशा वेगवेगळ्या रिसर्च स्टेशन्सवरती सुद्धा काय करते, ॲग्रिकल्चर मेट्रोलॉजी डिव्हिजन ह्या ॲग्रोमेट ऑब्झर्वेटरी काय करतात, इन्स्टॉल करतात. नाव द नेक्स्ट पॉईंट, ऑब्जेक्ट ऑफ ॲग्रोमेट्रोलॉजिकल ऑब्झर्वेटरी. द बेसिक aim or basic objectives of agrometeorological observatory, it is the study of relation of various weather parameters with the crop. That means the different weather parameters how affect growth and development of the crop at different growth stages of the crop or at different crop. That means they find out the negative and positive impact of weather parameters on the agriculture and different crop. So this is the basic or main objective of agrometeorological observatory. And they during this study or during recording of weather parameters, that means different weather parameters, those are affect on the crop, and the weather parameter affect on the crops are sunshine and cloudiness, temperature of the air and temperature of the soil, wind speed and wind direction, relative humidity, evaporation and transpiration, and last one is the precipitation, that means including the rainfall and snowfall. So these are the different weather parameters are affect on the crop growth and development. Already in theory lecture we are discuss about the different weather parameters, how they affect, that means positive and negative impact of this weather parameter on crop. And this weather parameter can be recorded in observatory by using different instrument. Now we discuss about the this weather parameter with their unit and which instrument are used for recording this different weather parameter in Agromet observatory. So first one, here see here element, name of element, their unit, that means the different weather parameter are expressed in which unit, also the which instrument are used for recording particular weather parameter. So first one, temperature having unit degree Celsius, degree Fahrenheit and degree Kelvin, and this temperature it is measured by the thermometer including the maximum, minimum, dry bulb and wet bulb thermometer, and also thermograph is used to measure the temperature. Here thermograph it is recorded continuous and automatic temperature. Next one, wind speed, this is the another weather parameter. It is having unit is kilometer per hour, meter per second, knot, etc. Units of the wind speed, and this wind speed is recorded in Agromet observatory by using anemometer and anemograph. It is used for automatic recording of the wind speed, and anemometer it is the manually operated instrument for measurement of wind speed. Next one, wind direction it is expressed in unit degree, that means 0 to 360 degree. It is the unit of expression of wind direction, or it is also expressed in direction. This wind direction it is also expressed in, that means unit is direction, and this wind direction it is measured by using instrument wind vane. Next one, relative humidity having unit is percentage, and this relative humidity is measured by the psychrometer or hair hygrometer, or also Asman psychrometers. Sling psychrometer, Asman psychrometers are used for measurement of relative humidity, or also hair hygrograph it is used in Agromet observatory for recording continuous and automatic relative humidity. That means for the automatic and continuous recording of relative humidity, hair hygrograph is used. Next one, precipitation including the rainfall and snowfall, and it is expressed in mm per day, that means millimeter per day, and this precipitation is recorded by using rain gauge and snow gauge, dew gauge, not rain gauge and snow gauge. If rainfall, it is for recording rainfall, rain gauge is used, and for recording snowfall, snow gauge is used. Next one, evaporation it is having unit millimeter per day, and it is measured by using instrument evaporimeter, United States Weather Pan Class A open pan evaporimeter. This evaporimeter is used for measurement of evaporation. Next one, duration of sunshine hours, and having unit hours, and sunshine recorder. These instruments are used to recording the duration of sunshine hours. Next one, cloud covers having unit is octa, and this scale of octa it is range between 0 to 8 octa, and for measurement of clouds any types of instrument cannot be used, only this is visual observation, that means it is seeing by eyes and recorded the cloud cover, how much cloud cover are present, or how much clouds are present in atmosphere. Next one, atmospheric pressure it is having unit millibar mm of Hg, that means mercury, pascal, kilopascal, hectopascal. There are different units of atmospheric pressure, and this atmospheric pressure it is measured by using barograph and barometer. I think in a theory topic about atmospheric pressure, at that time I show the different barograph and barometers for use to measure the atmospheric pressure. So these are the different weather parameters are recorded in the Agromet observatory and having their different units. Now we see the different instrument for use to recording the different weather parameters. So first one, this is the single Stevenson screen. This is the single Stevenson screen. The height of this screen, it is 4 feet above the ground surface. That means 122 centimeter from the ground surface. From ground surface it is height 122 centimeter. That means 4.08 feet. And this single Stevenson screen, including the 4 thermometer, it is used to measure temperature. That means here thermometer, 4 types of thermometer. It is maximum thermometer. This thermometer, it is used the maximum temperature of the day or in 24 hours or from last setting. The maximum thermometer, it is used to record the maximum temperature in a day or in 24 hour or from last setting. And the maximum temperature of the day, it is recorded at 2 p.m. to 4 p.m. at Indian Standard Time. But the time of observation of maximum thermometer is different. That means at Indian Standard Time it is at 2 p.m. or at local mean time it is based on longitude, it is the 2:30 p.m. During studying the measurement of atmospheric temperature, we are discuss detail the time of observation of different thermometer, maximum thermometer, minimum thermometer. Just keep in mind the maximum thermometer having time of observation is 2 p.m. at Indian Standard Time, and this maximum thermometer, it is used to measure the maximum temperature in a day. Now the next, minimum thermometer. The minimum thermometer, it is used to record minimum temperature in a day. And time of observation of this minimum temperature, it is before the at 7 a.m. Indian Standard Time. 7 a.m. at Indian Standard Time. Now the next, dry bulb thermometer. It is used for measurement of current atmospheric temperature. That means at any time you can record this, or you can observe, or when you observe this dry bulb thermometer, the dry bulb thermometer show the current atmospheric temperature at any time. So in case of only dry bulb thermometer, if ask a question, the use of dry bulb thermometer, at that time they write the use of dry bulb thermometer to record the current atmospheric temperature, or it is used to measure the temperature of the dry atmosphere. So this is about the dry bulb thermometer. Next one, wet bulb thermometer. It is used to measure the moisture temperature of the atmosphere. This thermometer, it is continuously wetted by the muslin cloth by using distilled water. Just keep in mind, this wet bulb thermometer are used for the measurement of moisture in atmosphere or moist temperature or cool temperature of the atmosphere. And the combination of dry bulb thermometer and wet bulb thermometer, it is used to find out the relative humidity of atmosphere by using hygrometric table, or also known as the psychrometric table. It is similar to log table, hygrometric or psychrometric table. It is similar to log table. The log table, I think all of you, log table is used in 11th and 12th standard. So just keep in mind, for measurement of temperature, maximum minimum dry bulb and wet bulb thermometer is used, and the combination of dry and wet bulb thermometer also used for the determine the relative humidity. So this is about the single stem sunscreen, and the unit of this is degree Celsius, degree Fahrenheit and degree Kelvin. So these are the different units of temperature. Now the next, see here, maximum thermometer. Next, see here, maximum thermometer, minimum thermometer. Next one, dry bulb thermometer and wet bulb thermometer. Now next, it is the double stem sunscreen. Double stem sunscreen, it is the double in length as compared to single stem sunscreen, and height of this double stem sunscreen, it is also similar to single stem sunscreen. That means 4.08 feet from the ground surface and 122 centimeter in on ground surface, or that means from the ground surface the height of double stem sunscreen is 122 centimeter. So this is about the structure of double stem sunscreen, and this double stem sunscreen is included the two instrument, and first instrument is the thermograph. Thermograph, it is used to measure the temperature, and here hygrograph, it is used to measure the relative humidity. But these two instrument, it is recorded continuous and automatic temperature and relative humidity respectively. That means temperature recorded continuous and automatic temperature. Here hygrograph recorded continuous and automatic relative humidity, and the unit of this double stem sunscreen is degree Celsius and percentage. Degree Celsius and percentage. So this is about the measurement of temperature and relative humidity. So see here thermograph, here metal it is present, and it is the content of thermograph. And in case of here hygrograph, in this section the human hair is present, or human hair is attached, and based upon this human hair the relative humidity is recorded by using graph or pens. So this is known as the hair hygrograph. That means the content of the hair hygrograph is the hair, human hair, it is the content of the hair hygrograph. Now the next instrument, this is the grass minimum thermometer. This is the grass minimum thermometer, and this grass minimum thermometer, it is used to record minimum temperature of the grass, minimum temperature of the grass, and the time of recording of this minimum temperature is before the sunrise. This grass minimum thermometer, it is recorded at before sunrise, and after recording temperature of the grass before sunrise, it is kept in shadow area or in double stem sunscreen to reduce effect of solar radiation or temperature on that mercury. That means mercury is present in this thermometer. So this is about the grass minimum thermometer, and the use of grass minimum thermometer to measure or to record the minimum temperature of the ground surface or grass surface or vegetation area. Now the next, this is the soil thermometer. It is also used for the measurement of temperature of the soil. For measurement of soil temperature, these soil thermometer are used, and this soil thermometer is installed at different depth. That means at surface, from the surface to 5 centimeter, 5 to surface to 10, surface to 15, surface to 20, or surface to 30 centimeter height or depth. These soil thermometer are install. And this soil thermometer also including the mercury, that means the content of soil thermometer is mercury, and also the unit of this soil thermometer is degree Celsius, and the time of observation of this soil thermometer is 7 am 7 am and 2 pm, or sometime additional 5:30 pm, it is the time of observation. Just only keep in mind, the soil thermometer, it is used to measure the soil temperature at a different depth from the ground surface to the 5, 10, 15, 20 or 30 centimeter from the ground surface. So this is about the soil thermometer, or it is used for the measurement of soil temperature. Now the next, for the recording rainfall. For recording rainfall, there are two types of rain gauges are used. First one is the ordinary rain gauge. It is also known as the non-recording type of rain gauge with 20 mm measuring cylinder. That means the capacity of this measuring cylinder is 20 mm. That means at a time, or at a one time, this measuring cylinder can measure the 20 mm rainfall at a time, or at a single time. See here, there are different parts during the practical of measurement of rainfall. At that time we discuss about detail about this instrument. So just keep in mind, this non-recording rain gauge or ordinary rain gauge, it is manually operated rain gauge. It is used to record rainfall, and it is expressed in mm per day. That means how much rainfall is received in 24 hours. If rainfall received in a day or in 24 hours in is 2.5 mm or more than 2.5 mm. If rainfall received in a day 2.5 mm or more than 2.5 mm, at that time this day is called as a rainy day. This day is called as a rainy day. Otherwise, if rainfall is occurs but rainfall is received less than 2.5 mm, at that day is do not called as a rainy day. If day is in 24 hour or in a day, if rainfall is received 2.5 or more than 2.5, this day is known as the rainy day. And when rainfall receive 5 mm in day, 5 mm in a day, it is called as a cropped rainy day. Cropped rainy day. Rainy day means in a day rainfall received 2.5 or more than 2.5 mm. 2.5 or more than 2.5 mm. That day it is known as the rainy day, and this rainfall it is expressed in, that means the unit of measurement of rainfall is mm per day. This is the ordinary rain gauge. Now next, see here, there are different part of non-recording rain gauge, that means ordinary rain gauge. Now next, self-recording rain gauge. Self-recording rain gauge, this recorded continuous rainfall. Continuous rainfall, also intensity of rainfall, it can be calculated by using self-recording rain gauge. That means the intensity of rainfall, it is measured by the self-recording rain gauge. This rain gauge is continuous and automatic recording of rainfall is occurs in 24 hours. So this is about the self-recording rain gauge. See here, rain gauge, here there are different part. When we study the rainfall, measurement of rainfall, this practical, at that time we discuss in detail about the different part. Just keep in mind, self-recording rain gauge, it is used to record the continuous and automatic, or automatic and continuous recording of rainfall. Also rainfall intensity is measured by this self-recording rain gauge. Self-recording rain gauge, it is also known by the automatic rain gauge. Automatic rain gauge. So this is about instrument used for the measurement of rain gauge. Now the next, for the measurement of wind. That means in case of wind, here wind speed, it is recorded by the anemometer. So see this picture. This picture is the anemometer. The anemometer consists of three cup. There are convex and concave type. Also see here, this part it is known as the cyclometer. The it is like a speedometer of our vehicle. I think you know the speedometer of vehicle, that is motorcycle. Like that, here also the one meter is present, and this meter is known as the cyclometer, and the running of wind or the wind speed is recorded in the this cyclometer. This is also manually operated by recording observation on the basis of 24 hours. Calculate the wind speed, and this wind speed is expressed in kilometer per hour or meter per second or different unit like a knot, etc. So this is the wind anemometer. Next one, wind vane. Wind vane, it is used to determine the direction of wind. To determine direction of wind, there are basically main four direction: north, south, east and west. These are the four main direction, and there are also four also sub direction. And this wind vane, it is used to determine the direction of wind. So see here, this so see this picture, that means this arrow indicate the direction of wind. Our flag indicate, that means the arrow indicate the windward side, and flag indicate the leeward side. That means this is the center. At this center, the wind coming from this side, that means from south side, and it is goes toward the north side. That means the south, it is the windward side, and north, it is the leeward side. That means here the arrow indicate the windward side, that means the wind from which blow, and leeward side indicate, that means the flag indicate the wind blow to which, that means leeward. So this is about the wind vane. Now the next, evaporameter. That means here evaporation, it is measured by the using class A open pan evaporameter. So see here, this is the open pan evaporameter. It is the internal section of the open pan evaporameter. In that, water is included, and the water is lost by the temperature. That means the evaporation is occurs, and this evaporation is measured by this open pan evaporameter. Here also the thermometer is also included for the recording temperature of the water. And this evaporation, or this evaporation, it is expressed in mm per day. That means how much mm or millimeter water it is evaporated from that open pan evaporameter or class A open pan evaporameter. So this is about the measurement of evaporation. Now the next, sunshine recorder. So see here, this is the sunshine recorder. It is also known as the Campbell stroke sunshine recorder. This is used to record the bright sunshine hours or sunshine hours. It is based upon 24 hours or daily basis. In that day, see here, there are three cards are used: winter card, equinox card and summer card. That means when days are shorter, at that time winter, that means in winter season, winter card is used. When day are longer than night, at that time summer card is, that means when in summer season summer card is used. And when day and night are equal, at that time this card, that means straight card or equinox card is used. Equinox, day and night are equal. And when this card is inserted in specific season, the solar radiation reaches on this globe, and it transfer from globe to the cards, and after that this card is burned, and based upon this burning of card, how much sunshine or bright sunshine are available to crop in a day, it is calculated by using burning card. So see here, from morning 9 a.m. to 3 p.m. there are continuous burning of this card. That means this indicate near about 6 hours bright sunshine are available to crops. So like that, the by using canticle stroke sunshine recorded, sunshine is recorded in a day. That means sunshine having units hours per day. That means how many hours bright sunshine is available in a day or recorded in a day. Like that, next one also we discuss new parameter for measurement of dew. Measurement of dew gauge is used here. This is the red oxide plates, wooden plates. On wooden plates, the water droplets are deposited in night, and this water droplet, that means dew, it is measured before the sunrise, and the height of this dew gauge, it is 100 centimeter or 120 centimeter from the ground surface. This dew gauge, it is developed by scientist Dew Devyani. The scientists developed dew gauge for measurement of dew. So now next, this is the Asman psychrometer. Asman psychrometer, it is also known as the aspiration psychrometer. That means this is the aspiration psychrometer. It is also known as the Asman psychrometer because the scientist Asman discovered this psychrometer for recording the relative humidity in a cropped area, also dry bulb and wet bulb temperature in atmosphere or cropped area. In this Asman psychrometer, one dry bulb and one wet bulb thermometer are present. See, this is the dry bulb, and see, this is the wet bulb thermometer. That means the content of psychrometer or Asman psychrometer is dry bulb and wet bulb thermometer. It is also used for recording of relative humidity by using dry bulb and wet bulb thermometer reading. Next one, radiometry or radiometer. There are several radiometer. See here, pyranometer, pyrilometer, pyradiometer, piezometer, net pyradiometer, net radiometer. These are the different radiometers are used for measurement of radiation. That means radiation instrument. These are the radiation instrument used for the measurement of radiation. The electromagnetic energy travels from one place to another place. It is known as the radiation. Or the the energy, it travels from empty space. It is known as the radiation. I think we are discuss in solar radiation topic different radiation also. So these are the different radiations are used, radiometers are used for the measurement of radiation. Next one, soil moisture measurement. For the measurement of soil moisture, electric resistant block is used. Electric resistant block is used for measurement of soil moisture in soil. Next one, lysimeter. This is the diagram of lysimeter. It is used to measure the UO2 transpiration, and this UO2 transpiration is also expressed in mm per day. This instrument, it is the lysimeter, and it is used to measure the UO2 transpiration. That means evaporation plus transpiration from soil and cropped area. Next one, so these are the different weather these are the different instrument used for the measurement of weather parameters. So, and these weather parameters are affect on the crop growth and development. Now we see about the next point, the procedure, that means for installation of Agromet observatory, following procedure or knowledge about the following points. This is known as the basic knowledge about the agrometeorological observatory or for the installation of agrometeorological observatory. And this knowledge, that means uh, the points, these 10 points are necessary for installation of Agromet observatory. That means during installation of Agromet observatory, this point should be considered or this point should be checked out. So first one, for the installation of agrometeorological observatory, the first point is the classification of agrometeorological observatory is also known. That means knowledge about the classification of agrometeorological observatory, it is a necessary. Next one, selection site and location of the Agromet observatory, plan layout of Agromet observatory, instrumental observation, installation, exposure of instrument and recording of data, also non-instrumental observation. Next one, recording observation on plant. Next one, hours and order of observation. Next one, recording and transmitting data, standard periods and weeks. Also climatic data of the station and region. Also network of India Meteorological Department of Observatory is essential. So the knowledge of this 10 point, it is necessary for the installation of agrometeorological observatory. Here one point is important for the objective purpose. The IMD stand for IMD stand for India Meteorological Department, not Indian. INDIA, India Meteorological Department. So now we discuss in detail this 10 point one by one. So first one, classification of Agromet observatory. World Meteorological Organization, that means WMO, having headquarters is Switzerland, Geneva. This by this WMO, that means World Meteorological Organization, the agrometeorological observatory is divided into four types or four category, and these category are A, B, C and D. These are the four basic categories of agrometeorological observatory is classified by the World Meteorological Organization. That means the types of observatory are four types, that is the A, B, C and D type. Now we discuss in detail about the classification of type of agrometeorological observatory. During study the type and the classification of agrometeorological observatory, in that we study about the name of observatory, also which observation should be recorded in observatory, also the observation recording of different weather parameter, which instrument are essential or which instrument are optimal, that means optional instrument in different types of agromet observatory. So first observatory, that means A type observatory. The A type observatory, it is also known as the principal agromet observatory, and these types of agromet observatory, it is present at IMD, that means in India Meteorological Department, and this IMD A type of observatory, it is installed at Pune Agricultural College, Shivajinagar. I think for practical exam purpose, this sentence, it is important. A type of observatory or principal agromet observatory, it is located at answer is the Pune, and it is established by the IMD in Agriculture College, Pune, Shivajinagar, Pune. And in this observatory, the recording of meteorological, biological and agricultural observation are recorded. That means in case of meteorological, all meteorological or weather elements. In case of biological, that means insects, pests are recorded. Also in case of agriculture, that means different crop observation, like height from date of sowing to the harvesting of the crop. There means germination, emergence, different reproductive growth stages, also leaf number, etc. are recorded in A type of or principal agromet observatory. And the instruments are essential in A type of observatory. For recording temperature, single stimulation screen are necessary. That means in single stimulation screen, dry bulb, wet bulb, maximum and minimum thermometer are included. Also for temperature, grass minimum thermometer, and for soil temperature, soil thermometer are installed. Also next, for recording rainfall, non-recording, that means FRP, non-recording rain gauge with the 20 mm rainfall measuring cylinder is necessary. Also self-recording, that means automatic rain gauge is also essential. Next one, for measurement of point. For measurement of point, in case of speed, anemometer, and for direction, wind vane is used. Also for evaporation, class A open pan evaporimeter is used. For sunshine hours, sunshine recorder is used. For dew gauge, dew gauge is used. Also for recording temperature and relative humidity in crop area from zero surface height, Asman psychrometer or aspiration psychrometer is also used. Next one, double stimulation screen, that means autograph, that means automatic and continuous recording of temperature and relative humidity. For that, double stimulation screen, that means thermograph and here hygrograph is also used. For measurement of radiation, radiometer, that means net solarimeter, pyrometer. These radiometers are used for measurement of solar radiation. Also for the measurement of soil moisture, electric resistant blocks or another soil moisture equipment are used. Also non-instrumental of agro bio observation, that means bioagro, that means insect pest and different crop observation are recorded. These are the essential instrument. Now the next optional instrument in case of principal agromet observatory, that means A type of observatory. Here lysimeter, portable potentiometer, microvoltmeter, thermopiles, recording contact anemometer, these are the optional instrument in A type of agromet observatory or principal agromet observatory. Next one, B type of agromet observatory. This B type of agromet observatory, that means ordinary agromet observatory, and these types of agromet observatory, it is established or installed in any research station, state agriculture university, or different agricultural colleges. That means in our college campus, B type, that means ordinary agromet observatory is installed. This point, it is important for the practical and exam purpose. That means there may be possibility to ask the question, which type of agromet observatory it is established or installed in your college campus, and the answer is B type agromet observatory, that means ordinary agromet observatory. And in case of B type of observatory, the observation are recorded like a routine meteorological, bio and agricultural observation, that means different weather parameter, insect and different crop characteristics are recorded. And for ordinary agromet observatory, that means B type of agromet observatory, the essential instruments are for measurement of temperature, single stimulation screen including the dry bulb, wet bulb, maximum, minimum thermometer. Also for soil temperature, soil thermometer is used. Next, for rainfall, only non-recording type rain gauge is used with the 20 mm capacity rainfall. Also for wind, for recording wind speed, anemometer and direction, wind vane is used. For evaporation, class A open pan evaporimeter is used. Next one, for recording temperature and relative humidity, Asman psychrometer is used. For measurement of soil moisture, electric resistance block plus bioagro observation are also recorded in B type of agromet observatory. And in case of B type of agromet observatory, optional instrument are self-recording rain gauge, sunshine recorder, dew gauge, double stimulation screen with the thermograph and here hygrograph. So these are the optional instrument in case of B type of observatory. Now the next, Auxiliary Agromet Observatory. In case of auxiliary Agromet Observatory, that means C type of observatory. In observatory, agrometeorological and biological observation are recorded. Routine agriculture, meteorological and bioagriculture observation are recorded. And for recording of these weather parameters, essential instruments are for temperature recording, single Stevenson screen, including maximum, minimum, tribal band, mid bulb thermometer. Also, for soil temperature, soil thermometer is used. For rainfall, non-recording, that means FRP, non-recording rain gauge with 20 mm rainfall measuring cylinder is essential. Also for soil moisture, electric resistant block is used, and also potential UFO transpiration is recorded. What is meant by potential UFO transpiration? Potential UFO transpiration means it is a UFO transpiration rate at a unlimited water available to the crop. That means when unlimited water is available to crop, at that time those UFO transpiration is occurs. This UFO transpiration known as the potential UFO transpiration. That means like a geo, unlimited data is available at that time, maximum data is used. This is known as the potential UFO transpiration. Also next, bio and agricultural observation are recorded. And the optional instrument in C type of agromet observatory is anemometer and wind vane and dew gauge. These are the optional instruments in C type of agromet observatory. Now the next, specific purpose agromet observatory. In case of specific purpose agromet observatory, these types of observatory, it is a temporary or permanently basis. That means for recording of weather parameters for temporary or for permanent, this 4 or D type of agromet observatory, that means specific purpose agromet observatory is installed for recording one or several elements of specific phenomena. So this is about the our types or classification of agromet observatory or agrometeorological observatory. So this is about the types. Now the next point, site selection of agromet observatory. I think the site selection of agromet observatory, in case of this is the second point in our procedure, site selection of agromet observatory. In case of site selection of agromet observatory, these following 11 points should be considered while selecting site of agromet observatory. So see here, in case of agromet observatory, so first point, the location of this agromet observatory should be center of farm, and the size of agromet observatory, it is 15-meter long north to south and 36-meter width from east to west. That means the ideal dimension of agromet observatory is 55 north south to 36 east west in meter. That means 55 meter north south and 36 meter east west. This is the ideal dimension of agromet observatory. This is kept in mind for all competitive exam purpose in relation to agriculture. That means the banking, it may be for agri MPC, it may be for also MCR purpose, or also for semester and theory exam, practical exam purpose. The ideal size of agromet observatory is 50-meter long north south and 36-meter width east west. This is the ideal size of agromet observatory. Now the next point, the site should be perfectly level. That means those area is selected for installation of agromet observatory, the area should be level. Also next, its site should be free from waterlogging. That means in rainy season, any types of water cannot be logged in this agromet observatory area. That means the site should be free from water logging. Also, this area or this observatory, it is easily approachable for the recording of observation. That means the road also necessary, and suitable road is also necessary to avoid the difficulty in recording observation in rainy season. That means no waterlogging condition is no waterlogging condition in Agromet observatory. If waterlogging condition is observed or occurs, at that time the observation of weather parameters or taking observation of weather parameter is difficult. So road is easily approachable, or observatory is easily approachable by the roads. Also next, this observatory, it is away from, or site should be selected like that. This selection site or the area should be away from the any hill station, also from forest, also from irrigation canal, also from tanks, or also from any water reservoirs. If any water reservoirs, forest, or any area like irrigation canal, forest, hill, tank, water reservoir is available or near to the observatory, it affect on the weather parameters. I think you know, land bridge, sea bridge, like that. It affect on the pressure, that means the air movement, also temperature, relative humidity. That means actual observation could not be, or actual observation cannot be recorded in observatory by different instrument. So for that, the site should be away from the hill, forest, irrigation canal, tanks, and water reservoirs. Also, this observatory, it is away from the building. If the building is present near to the observatory, that means the height of building is suppose uh, 10 feet, 10 feet, suppose 10 feet. At that time the observatory is away from that building, it is about 2 to 3 times of the height of this building. Suppose here height is 10 feet, that means from 20 to 30 feet from this building, 20 to 30 feet, the observatory should be installed to avoid the effect of wind or building or tallest object on weather parameter, or in case of observatory. Also, this observatory is installed in which area? The area should be preferable by the ideal types of soil. That means in case of agricultural college or any research station, there are two types of soil: clay types of soil and sandy types of soil. If the crop is cultivated in clay types of soil, and observatory is installed in sandy types of soil, at that time these weather parameters are not applicable, or this is not applicable for the correlate the relationship between the crops cultivated in clay soil. That means those soil are used for the cultivation of crops. These types of soil is also preferable, or representative types of soil should be necessary. That means in that type of soil, uh, installation of Agromet observatory is necessary. Now the next, in case of Agromet observatory, all sites, all sites, particularly eastern sites and western sites, it is away from free structure or big structure. If structure is available, suppose in case of east side any structure is available, and this the observatory should be away from this structure by 10 times of that object, or height of that tallest object. Suppose there are forest area, or a building is present and building height is 40 feet. Suppose at that time 10 times, that means 400 feet away from 400 feet, this observatory is installed from east and west direction to avoid the effect of tallest object on the Agromet observatory, or recording the observation or weather element. Next one, site should be enclosed. with the beard wires or finishing of 2.5 meter height. That means the here finishing of this Agromet observatory or different weather instrument by the finishing wire or beard wire finishing by using poles. That means from ground surface at the height of this finishing wire or a gate also it is the 1.20 meter height from the ground surface. From the ground surface 1.20 meter height wire finishing or beard wire finishing is necessary. Also next and last, suitable locking system is necessary to for the suitable locking system or arrangement of suitable locking should be provided in point of view of safety of instrument. That means for the safety of instrument the suitable locking system should be necessary for a gate. Like that the different points should be considered while site selection of Agromet observatory. So this is about the 2 points in procedure. First one, classification of Agromet observatory, and second one is the selection of site of and location of Agromet observatory. That means point should be selected or point should be considered while selecting site of Agromet observatory. Like that our this lecture I can stop here. In next lecture we discuss about the remaining type points in the procedure, like a plan layout of Agromet observatory. Also different points we are discuss in next lecture. In this lecture the or in this site selection, this is kept in mind. Size of Agromet observatory, ideal size of Agromet observatory. This is important for the semester and theory practical exam also. Thank you. Remaining points or remaining practical we are discussing next lecture.